measures of spread. We've looked at the median already. Now we're going to look at some quartiles. If the median cuts it in half, the quartiles, as the word kind of says, a quarter, splits it into quarters. And sometimes your median is called the second quartile. So the first or lower quartile, which sometimes is written as a Q with a little 1, is the middle value of the lower group of data. 25% of your data is less than that first quartile, and the other 75% is bigger than the first quartile. The 50th percentile is sometimes called the second quartile, because if you have 2 quarters, that's like 1/2. Then we have our third quartile. We already learned that the range is the difference between your smallest value and your biggest value. And different than what, when we write range for a graph, we would often say 2 is less than or equal to y is less than or equal to 6. In statistics, if it went from 2 to 6, you would just say the range is 4 and not give those parameters around which the parameters actually give you more information. But in statistics, we just say the range is 4. And then we might also tell you, oh, the minimum's 2 and the maximum's 6. That would tell you more information. Another range that we look at is the interquartile range, which is just the range between quartile 1 and quartile 3. The interquartile range gives you the middle 50% of people. Now this is used in a bunch of different things. The middle 50% is often like, oh, when they're designing clothes, we'll make clothes so that they fit the middle 50%. If you're one of those people that is outside of that middle 50%, it's like, oh, I can never find shoes. Right? I have a cousin, can never find pants, can never find shoes. He happens to be 6'9". He falls well out of that middle 50%. He's my tallest cousin. And an outlier, extreme or distance values. My cousin, who's 6'9", might be considered an outlier because he's so tall. Okay? In my family, I might be considered an outlier because I'm the shortest cousin. I have tall cousins. And my brother is taller than me. So on that side of the family, at 6 feet, I'm the shortest. I have cousins that are 6'9", 6'7", 6'5", 6'4", 6'3", 6'3", 6'2", and then me, little me. Little me. So we consider an outlier an extreme or distance value, and the way that we calculate this is we go to quartile 1 or quartile 3, and if something is 1.5 times whatever the interquartile range was, above that or below that, then they would be considered an outlier. Here's our data. The first thing you're going to do with data is rewrite it from smallest to biggest. Whew. Again, I wrote things underneath just so I matched up that I had the same amount of numbers that I began with. That's good. Now with 9 values, your median is going to equal 6. Are you good with the median value being the 5th one? You could use that formula. 9 plus 1 divided by 2 is 10. Here, you have enough fingers. You could put up 9 fingers and see that the 5th one is right in the middle, 4 on either side. What about quartile 1 and quartile 3? quartile 1, and quartile 3. We need to find which value happens in the quarter. A couple of ways you could do this. One, in this situation where you have a median, there's 4 below and 4 above. In the 4 below, can you see that that's right in between? Quartile 1 in this situation would be the average of 4 and 5. It would be 4.5. Quartile 3 is 7.5. The range of this values, we go from 3 to 9, so we would say that our range is 6. Our interquartile range is 3. So if we can visualize the data as we could in this situation, we can see our quartiles in that lower half. We take half of that. There's 4 values. We don't count our median value because it's already been considered. In this next one, if I rewrite these, 10, 11, 11, 12, 13, 15, 18, 25, there's 8 terms. The middle is right in between the 4th and the 5th term. Interquartile range is what is the number between quartile 1 and quartile 3, how much of a value. If we go from 4.5 to 7.5, that's a distance of 3. So the range, interquartile range, would be 3. Just like we found out the actual range from 3 to 9 was 6. So here, our median is going to be 12.5. In this situation where the median is right in between the 12 and the 13, we would look at our bottom half and say there's 4 numbers. What number is in the middle? It's going to be between the second and the third one. So our quartile 1 is the average of 11 and 11. And quartile 3 is going to be the average between 15 and 18. Okay? Now, these are ones that you probably can see the middle between 15 and 18 with ease, because the numbers are small. But if that was between 15 and 180, I don't think you'd say, oh, I see what the middle is right away. So what's another way that we could find out that this is 16.5 between 15 and 18? 15 plus 18 is 33, divided by 2, 16.5. That's what an average is, right? Take the two things and divide it by 2. Sometimes you could just see it, like the 11 and 11. 11, yeah, that was a good one. Okay, and the numbers are small, but otherwise it's good that we have a way of doing this, that we could just add 15 plus 18 divided by 2, get 16.5. Okay, our range in this one is 15, because we go from 10 to 15. Our interquartile range, we go from 11 to 16.5, is 5.5. Remember how I gave you a little formula for the median to be n plus 1 divided by 2? You could also use a similar formula for quartile 1. N plus 1 divided by 4. And quartile 3 is just 3/4. So if the first quarter is n plus 1 divided by 4, 3/4 would be 3 of those. Okay, we're going to do the 25 as an outlier first. I want you to, we're going to look at these formulas and then I'll give you an example where the formula actually works out to be a really nice number, and we'll see how that fits. So first of all, in the first one, how many terms did we have? We had 9 terms. If I do 9 plus 1 divided by 2, I get the 5th term, which worked out perfectly to be the 5th term. If I do 9 plus 1 divided by 4, I'm going to get 10 divided by 4, which is 2.25. 2.25 is between 2 and 3. That's why our quartile 1 happened between those two. If I do 2.25 times by 3, I'm going to get 6.75. That's between 6 and 7. Notice, no, sorry, 2.25 times by 3, yeah, 6.75. 1, 2, 3, 4, 5, 6, 7. No, something went wrong. 10 divided by 4 is 2.5, not 2.25. Thank you. And if I do 2.5 times 3, I get 7.5. And 7.5 would be between the 7th and the 8th one. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it's in the right spot. Here we had 8 terms. 8 plus 1 divided by 2 is 4.5. Sure enough, we had to take the average of the 4th and 5th one. 8 plus 1 divided by 4, 9 divided by 4. I think I was maybe getting a little bit ahead of myself with my math. Is what? 9 divided by 4? 2.25. 2.25 is between 2 and 3. We got quartile 1. 2.25 times 3 is 6.75. 1, 2, 3, 4, 5, 6. Between 6 and 7 was quartile 3. Does it ever work out that quartile 1, the median, and could you have quartile 1, the median, and quartile 3 all be nice numbers? Yes. Let's say I had 7 terms. 2, 4, 6, 9, 11, 14, 17. That's 7 terms. Does that make sense that that's the median? Can you see that this is quartile 1 and quartile 3? If I have 7, do each of my formulas work out nice? They do. 7 plus 1 is 8. 8 divided by 2 is the 4th one. 8 divided by 4 is the 2nd one. So when the numbers are small, these formulas, you probably don't need them because you have your list of data. But when numbers get bigger, especially if you have a grouped frequency table, that's going to be helpful for figuring out quartiles and medians. Is 25 an outlier? Well, our definition of an outlier is to figure out if something is 1.5 times the interquartile range, bigger than quartile 3 or smaller than quartile 1. Obviously, 25 is a big number, so we're going to check out what is quartile 3 plus 1.5 times the interquartile range. Well, quartile 3 we know is 16.5. The interquartile range we know is 5.5. So this becomes 16.5 plus, can someone check my math, please? Is that 8.25? Yes? Good. And add those up, we would get 24.75. Since $25 is greater than quartile 3 plus 1.5 times the interquartile range, it is an outlier. If you plug these numbers into your calculator into list 1 and use stat calculate, your calculator tells you quartile 1, the median, quartile 3. It doesn't tell you the range, but it tells you the minimum and the maximum. So a little bit of subtraction should get you the range. It doesn't tell you the interquartile range. It doesn't figure out this value of when something is an outlier or not. But all of those things are relatively simple to calculate. All right, I'd like you to try example 2 and 3 on your own. I'll put up the answers in a bit. The median is going to be the 11th term. That happens to be 6. The lower quartile would be the 5.5 terms, so the average of the 5th and the 6th one. Both the 5th and the 6th ones are 5, so quartile 1 is 5. Quartile 3 is going to be the 15.5 term. 15 is 8, 16 is 8, so quartile 3 is 8. And our interquartile range is 3. So the first thing I did was add it up to find out there was 21 in total. Remember how to read a group frequency table? That the first value is the value, and then the second number is how many you have of that value. Because quartile 1 was 5.5. Quartile 3 will be 3 of quartile 1s, which is the 15.5 person, which has to be between the 15th and the 16th person. When we look at our chart, 16.5, thank you. Yeah. That's right. So the 16th person happens to still be 7, 14. 16th person still happens to be 8, and the 17th person happens to be 8. So quartile 3 is still 8. Whew. Thank goodness. So what we have with a frequency chart is when that 4 has a 2 beside it, you could start imagining writing out this data. I'll go up here. I have 2 4s. Then I have 5 5s. This is what it would look like if it was a list of data. 4 6s. And you can see why it gets a little annoying to have to write them all out. I'm going to run out of room even. Maybe not. 2 10s. 1 12. Ah, nice. There's 21 items. Then you could count the one in the middle at 11 and see that it's a 6. But what do we do instead? We know it's 11. Here, I'm up to 7 people. Here, I hit my 11th person when I get to my 6. That's how I can use my frequency table. Because I don't think you want to write out all 21 of them. Or even worse, when it gets to like 220 people. Yeah, just give me a second. I'll write them all out. Okay? But it's good to be able to say or visualize, can I visualize that this table of data means that? And if I can, it's going to make more sense to me how I got quartile 3 to be 8. Some of you are going to write down quartile 3 to be 16.5 sometimes. Whew. All right. Did you get k was equal to 4? And your median to be 3, quartile 1 to be 1, quartile 3 to be 5, interquartile range to be 4. this is where I'm going to give you a puzzle to end with. And this is where we're going to end today. Our next class is on Wednesday. And on Wednesday, since it starts with W, we will do a topic that involves the letter W. Whisker plots. Sounds intriguing. But your puzzle for the end now is, I want you to find a set of numbers where the median equals the mode. M's not a very good letter for this, is it? Equals the mean, equals the number of terms you have. And it's possible to do this if n equals 5. What does this mean? There's 5 terms. The mean is 5, the median is 5, the mode is 5. What are the 5 numbers? You could have all 5s as one possibility. Are there other possibilities? Yes. So one possibility is exactly that. If you had all 5s, does it make sense that your middle number is 5? Your mode is 5, obviously. You have that number the most. And your average is 5. That's one possibility. Can you find another possibility? Okay. Oh, and should I add to it, should I add to it, the range is 5? Yes. Let's add to it that the range is 5.